That's dangerous.
Do you want us to do attendance?
You can if you want.
Dr. Snippy says yes.
Yeah, do attendance, but the real attendance was the knowledge you gained.
What knowledge?
Well, you should do the lab.
Computer Club presents tomorrow at Student Senate, so woot.
That was very faint, but I think you said something about Senate.
Computer Club is presenting at Student Senate tomorrow, so attendance is important.
Okay. Good to know. That will not change my life in any way, but good to know. So here's a quick insight into lab development for me is I boot up the same Linux container, and then I SSH tunnel out of it. And it's really funny because I've been using the same one for like a month. Anyway,
So
on
you're
the back.
saying it would be bad if it would just turn off?
I mean, I got backups, and it's just Linux, so
No, you just tested.
you can't lose Linux. Cool, web box. Okay, this is the wrong container, but that's okay. All right, let's talk about Bash. Was that a question or?
No.
Okay. Welcome to Bash. What is Bash, you may be thinking? And think no more, because that is not required. Is it bashing your head against a wall? No. It is a shell. A shell you type words into, usually commands, that do things. So hopefully you're familiar with this. This is kind of a joke slide, but hopefully you know that Bash is the shell that when you open the terminal, you type things in it, that's a shell. Cool. And here's an environmental variable. So Bash scripting, not a lot of people know this, but you can put Bash commands in a file, and then you can run it. And that's a script. That's it. That's the whole thing. You see, I wrote this in the command line, and then I put in a file and I ran it. That's it. Thanks for coming. So I'm going to create a tunnel out of this so you guys can join me in what? No, yeah, I mean, you can if you want. I'll give you root, but that would be kind of mean if you deleted the entire box. Hey, you liked it. Okay, so thank you to Mr. Andrew Kramer for hello everyone. Hi. So you guys can join at devsec.club port 4015. This is an SSH tunnel. At the tunnel user. And now there's a tunnel. So you should be able to connect outside the environment, which I'm going to do now. TSU at devsec.club port 4015. And then I'll be like, wow, okay, well, that's kind of rude. And this is the part where I delete my known host. And it's like all happy. So that happened because the server behind the IP address and port changed. So I thought it was like I was trying to be man in the middle. And the password should be pass1bay. There we go. So I hope you guys followed that. No? Okay, well, here's the command again. If you want to join me, hang out on the box. You can do this from any command prompt, any modern Windows, any Linux. Okay, cool. Okay, so back to the presentation. Here's a brief history of shells. So basically, Bourne shell, some dude named Bourne made a shell, and he named it SH. And then a bunch of people made a bunch of other things. Like the Almquist shell is basically SH, but they ported it. They like made a copy or something. I don't know why, but it's slightly faster and more features. And then they made Dash, which was like a Debian one in 1997. So SH and Dash are like the same thing. They're POSIX compliant. It's supposed to be like a port of a port of a port. So then I found two stock images and I thought that was funny. And then there's C shell, which you'll find on BSD a lot. And then there's K shell, which is corn shell. And I don't know anything about that. But what the bread and butter, what we're here for, is Bash, which was made part of the GNU project, which I hope you guys are familiar with. So if you see that sh is actually a lie. It's actually dash. They're trying to trick you. So when you type sh, it's actually not the original sh. Is my point. Fantastic. POSIX, portable operating system interface. Basically, that's a lot of text, but essentially it lays out ways that certain things should work. So if they don't work that way, people get angry, and it's for the sake of portability. So if I use a script that does echo $$ to get the PID of the current terminal, that won't work in other shells. And it wouldn't work really anywhere else unless POSIX was a thing, which is, so it works places. That's part of the standard. But you see in fish, it's like, that's not the thing, and it gave me a little helpful message. Why didn't it just work instead of giving me a helpful message? I don't know. So you guys hopefully have seen the shebang when you make a shell script, and it's like #! and then a path to a thing. That's the alternative when you just run it with exec_ve, like // it reads the first line. And then it's like, yeet. Welcome back to the box. I see there are 2 other friends here. So if we're making scripts, I'm gonna hang out in root, and I want to run it. What? Okay, we're installing them. Does anyone have questions on shebang? Galen, can you watch questions? Concerns on anything? Anyway, here's a bunch of screenshots that you can look at. So shebang is more versatile than you might expect. The number one, the classic, is you put the little thing on it, right? And then it runs it as bash. But you can also use the environmental inv command, which will use the path and find out which binary of this name is earliest in the path, which is how it normally works. But if you don't want to hard code a path, you can be like inv, where is bash? You can do that with Python too. So it still works. And then here's the man snippet that I screenshot. But it actually will work with any command. So if you want to run cat on a file, you can just put bin cat. And then I made a script that reads itself. Pretty cool. And by default with bash and sh, you can just put nothing and will still work. But that won't work in like fish. So here's what I was trying to do, some jank, where I made it user bin group, and then I made the file a username. So then I would run groups on the username. But it didn't work because it took the absolute path. Does this make sense? No? Okay, that's unfortunate. This is where it runs the thing. Okay, so here's an example script. Shebang at the top, and then a while loop, and then that's it. So note that script is kind of worthless because who's going to be watching W? I don't know. If you're not familiar, W is... Okay, I have Vim now. I could be like bin bash. I was not. Did my terminal die? Okay, we're back. W go like that. And see, I just put W in a file, and now I can mark it as executable. Capital X is not a real thing. And then I can go like that, and it runs it. So that's literally equivalent of typing W in my terminal, which is who, or like some form of who. Pretty neat. I can also run it like, that's not a thing. I can also run it like that. Pretty cool, pretty poppin'. So in this I added a control structure of while. So while true, do this thing. So if you had to guess what this would look like, it would be like who, and then it would sleep for a second and then clear the screen, and then who, and then sleep for a second, clear the screen. You can put this in a script, or it's so short you might as well just put it on the command line. So if I were to put it on the command line, I'd be like, and then it would just do it. So it waited 1 second, clears it. This is a very inefficient way to do it. It's just here to demonstrate things you can do. So does this sample script make sense? If that makes sense, then you're pretty much bash god already. All right, assuming silence means yes. Welcome to the bash course. Hold your laughter, please. So comparison, if you want to do things that return 0 or 1, that's how bash handles it. So instead of doing like trues and falses, if you have something that's 0, it means go forward true. And if you have something that's 1, it means, or non-0, and that means bad, which is kind of confusing because in C, 1 is true and 0 is false, but they did a switcheroo. So 0 execute means good, is essentially the thing. So if you've done bash scripting, you've probably seen these little brackeys. But what they don't tell you is that actually a command. The bracket is a command. They're hiding everything from you. So if you see this, shush script, It's a command. It's a command. User bin bracket. You didn't expect that, did you? And if I run like string comparison, it'd be like, okay, well my terminal's dead, but it'll process it anyway. There we go. And then it's like it didn't return anything, but what it did do is return execode. So if I do that, I can see this is a 1 because string 1 is not equal to string 2. If I go back and say string 1, 0. Mind's blown, presumably. Thank you, ceiling person. So string comparisons is equal sign and not equal sign, which is an exclamation mark equal sign. And then you do integer comparisons with -eq or -ne for not equal, equal, not equal. You get it. Okay, so I'm here. Welcome to some control structures. So the bash gimmick that is humorous is you put like if here, then it's going to be phi. If you do case, it's going to be esac, so they reverse it. And it's really funny, except they don't do like elo, they do done. So for loops and for while, it's just done, which is kind of disappointing. Anyhow, condition is the thing you saw on the previous slide. So anything that returns 0 or 1 can be treated as a condition. So if I did like if true, it's going to be true. True is also a command, I think. Classic. And if you wanted to find a function, you can do that. All you do is you put the function name, and then you put a little, you actually don't pass anything. It's just saying it's a function. You put a little parentheses. And then in the brackets, you do what you want. Let's get it. So there's a more advanced sample. It's saying if W and then tries to find grep quiet, whatever you pass as the first argument. So if you say like /script username, like this is $1 in the script. And then it's going to try to find $1, the username, in W output. That's kind of like a briefly useful script. If you want to see someone logged in and you don't want to read more than one line of output, it'll save you. Variables. If there's a $, good chance it's a variable. That's pretty much that. Environmental variables are pretty common. So like sudo user, that'll be a variable set whenever you launch something as sudo. And shell is the current shell you're using. You saw that on slide 1. Command substitution is pretty darn useful. I use it a lot, I guess. Usually when I want to see exactly what something is. So if I go over here and I'm like, is ls fake? Then I can be like, which? Or I can be like ls law, which is funny. I'm using ls to determine what ls is. I'll be like, no, it looks real to me. Or if I do the same thing with sh, I can see that it's actually fake, and it points to dash. Once again, conspiracy. And then subshells is just when you do something like this. Eck is not a command. So this actually spawns in a new PID. It makes like a copy and a fork or whatever. Go away. So that's that. Does that make any sense? I kind of flew through this. There's no way that makes sense. Thoughts? Stupendous. Okay, so you can print with echo. It's like print. Except you print things. Okay, I don't know why my O key is broken. There you go. Questions on print? Didn't think so. If you want to use escape things like new lines, I want there to be a lot of new lines. Wonderful. You can also do ANSI color codes, which are awful, but they look like this. And you see that's a slightly different color. That's a different color right there. You can do colors. The world is a wonderful place. Okay. So describe to me what is the issue with all of these. Explain TAC-E. TAC-E processes escapes. So what?
And explains.
Okay. So you see this, like echoes literally the thing I typed in it. But if I wanted to make it a tab, I could do -E. So it's saying take these two combinations, take this combination of normal characters and make it into a special white space object or something you can't normally type. Like how do I type a tab? You press tab, but that's actually already something. It's autocomplete. So I can do this, and then it puts a literal tab object in front of it, which you wouldn't be able to put otherwise. Like likewise, I can't type a new line because that means send the command. So what I would have to do is I'd have to do something like that. and then that would process however many \n's I put and make it in the output. Hopefully that explains that. And you can do the same thing, but more advanced with these ANSI color codes, which look awful. These. And then you make them different colors. Yay. Okay, hopefully that explained that. Welcome to Bash Lightning Round. There's an issue with all of these. Taking comments from anyone.
The user isn't running the variable. It's just printing out that command that you typed in.
Well, which one?
The middle left.
Yeah, okay. Nice work. That one's solved. So this should be a command substitution, not just a string. You should put a little $sign in a parenthesis. What?
That's PHP.
Okay, well, Galen's comment is this is PHP, but the real issue with this is if you want to assign a variable, you don't do a $sign when you're assigning. So this would just be, okay, I can't cover that with my thumb, but it would be just that, just mantra, like this one. The issue with this is it's if and done, which is not valid. It should be if and phi. The issue with this one is that you didn't escape the single quote, so it's going to say like, what is "sa good day out"? That's not a command. And the issue with this one is that you try to use a variable with no space. So favorite lettery-lophone is not a xylophone. So you're going to need to put curly brackets around the command to make it think it's not a big variable. That can be confusing, so I'm going to do an example for that one. Cool var LOL. And if I wanted to LOLW, then I could be like ec cool var W, except now it thinks it's a different, this isn't the cool var then W, it's cool var W. So it's nothing. But if I put little brackets around it, then it's LOW. That's what I meant for that one. Great.
Makes sense.
Cool. So script 1, watch SS. Okay, I spelled that wrong, but it's plunt. So here are two ways to accomplish the same thing. You can make a bash script. This is like essentially the same structure as the who one, except it lists listening ports. So SS plunt. It's like, hi, what's listening? We got SSH, we got Nginx, cups, systemd resolve, because this is the web server box. And I could make a while loop. And then you know the drill. Sleep one, clear, done. And then it's like, wow, that's so efficient. Except it hurts to read. And so instead, you could do the watch command, which makes it nice and pretty. So it says every 2 seconds, run this command. Sucks less? Maybe. Does that one make sense to people? Excellent. Script number 2, IP tables. This is not really a script, but just something you should really do. When you write a firewall and you put like the script on your box and you want to troubleshoot it, you don't want to be like clearing the entire firewall and then typing all the commands again like the IP table slave you are. What you should be doing is you should put in a file and then run the file. And then if any issues occur, you can just run the file and it resets it and sets it all up for you. So that's a much better route. So this is just a bunch of IP tables rules. I set the variable right here, and then I can use the variable as a command because it's just going to process it as a string. So that's so I don't have to type /sbin/IP tables every time. Thoughts, questions, concerns? Great. So this shows you a few new things. This shows for loops and arrays. So bash array is delimited by a space. So this is an array of 2 items called SSHD and dbus. So this is going to print plus services. And then it's going to be like for service in services. So it's going to run this loop twice, once for SSH and one for dbus. And then be like sysctl is active service, which returns a 0 or a 1. And then if it's active, and means do if the last one was 0. Then it's going to echo service up. And or means do if the last one failed. So this is kind of an idiomatic structure to be like run this if it worked, run this if it didn't. So you can run this, and then if it fails, you can delete the plus part if you only want to see output on fail. You'll know about it. Kind of rad. Moving on. Here are some change password scripts, which you guys could definitely use. The first one on the left sets one single password. So you type in the password. This right here is a read prompt, and then assigns to the variable p. And then it says for you and users, we'll talk about this in a minute, echo u p password. So password takes username, password, and then just changes it. So you don't have to do like the password standard in stuff. So you type in one password and it changes it for everyone on the system. Everyone on the system being determined by this command. So pipes, hopefully you guys know what pipes are. Be like, oh my god, eck. If I did echo he, you can pass it hi if you want. And then by, and it looks like this. And then I grep by, it'll just print the by line. So that's piping. I pipe the standard output of this command and standard output of that one. Hopefully you're familiar with that. So this takes get int password, which looks like this. If you'll notice, it is the Etsy password file. Okay, someone put root at the end. That's kind of concerning. And then you grep. This is E for regex. And then you grep for everyone who has /bin anything sh. So things that will get matched by this are like bin sh, bin bash, bin csh, bin fish. Anything that starts with /bin/ and ends with .sh will get matched. So for every line that has a shell in it, okay, well, I don't know if you guys are familiar with this, but this is the part at the end of Etsy password determines what gets run when they log in. So that's their shell. So if they have a real shell there, that means they're a user, is the idea. And then cut. So delimit on colon, the first field of the line. All right, this is getting too confusing, so I'm just going to do it. So get in password, and then I'm like, okay, that's too many people. So I'm going to grep E for this. So this only says people with bin bash or bin something sh, right? I explained the regex. So now we're down to 4, but I only want the part, hi. But I only want the part in front of the colon. So I'm going to use cut, delimiter of colon, and then the first field. So then I just have a list of usernames. And I'm like, wow, there's 2 roots and a howdy Shane. That's not normal, but that's okay. And then I don't want to change root password, so I'm going to grep out root. That's inverse. And then I have my list of users. And it's all happy, all for forever. So I can be like users equals that. And now when I echo US, it's a array, a space delimited list. So I can be like for you in US, echo user is you. Done. I need a do right there. No, I deleted my semicolon. There you go. So it iterates over each user. So we can see how this would be useful. If my password was password2@, oh no. Then it would be like user is, and if I delete user and then I pipe it to chip password, I have a password change script. Success. So hopefully that made sense. Questions in chat or Galen will yell at me. For this one over here, we'd use the exact same line to get the users, and then for each u and users, we echo it, and then this is a command substitution where it takes the current nanosecond, hashes it, and then takes the first 10 characters of the hash. So this is meant to be pseudo-random. Essentially, they won't be able to guess the nanosecond, and if they are, then they'll be changed in a second anyway, because the script will run like every second. And this is meant for competition where you don't need to submit password changes, because it just changes passwords every second, pretty much. You put this whole script in a while loop. And then it just echoes the current nanosecond hash in the first 10 characters with cut. And then it pipes it to standard out and to chip password. So that's a T and then some input redirection to a subprocess or subshell. That's probably the most advanced crap we're going to do in this presentation. But if that makes an inkling of sense, then I'll call it a success. Cool. And here's one of my favorites. If you want to dab on the red team, you can copy this, which here, I'm going to set it up because it's funny. So first I'm going to make this file, and then I'm going to make it editable by everyone, because that's always a good idea. And then I'm going to go to my thing and copy this, because I don't want to type it. In a real competition, you would have to type it, but it's not that long. I'm just lazy. And then bin red is already probably a thing. Psh, nice try, ed. You're not a real editor. Okay. And then basically, if we analyze what this does, it's a function called ri that echoes root at hostname, like it's trying to fake a prompt, it looks like. And then it says read I. And then if this is a thing, it's not post-combine or whatever. If this does not exist, or if it does exist, z is does not exist. If the string is set, then echo this thing, command not found, and then pipe it to varlog commands. And then this is a trap, which means if you send these signals, run this thing, which is the loop. So it looks like it's a fake shell that tries to get red teamers stuck in it. So I'm going to get stuck in this. So I'm going to launch Tmux so I won't have to reconnect. Ah! There's nothing on this box. How can you live without Vim and Tmux? Okay, we're going to learn how to kill dpackage. That is not a thing. There we go. Teach it. Oh my gosh. You know, you don't get the graceful kill. And we're back in business.
It doesn't like their level card with Tmux.
We need to update. I need Tmux. I'm not even like memeing. Like this will be a lot harder without Tmux because then I'm gonna get stuck and then it's gonna be funny and you're gonna be like, haha, you have to reconnect. What a clown. Now we're back in business. All right. Give me my beautiful green bar. Okay, now we're in business. It's purple. That's okay. So when I type, if I chmod plus x, again, and x is not a thing, and then I'm like a red teamer, and I'm like, ooh, what is this red command? And then it's like, huh, this looks the same. But when I type Control C, it doesn't die. And when I type Control D, it doesn't die. And when I press Control Z, it doesn't die. And then when I type ls, it's like command not found. I'm like, and that's not a real thing, but it's like, who am I? Command not found. Nothing is found. So essentially, this is a honeypot. So it looks like a real prompt, but I can't exit it, and I can't do anything. It doesn't work. Control L doesn't even work. And then if you check, oh, okay, I've been stuck. If I check the log, I will be seeing a juicy log of exactly what the red teamer is typing. So that's the point of that. So cool bash scripting. And then script 6 is a script of mine that I wrote that shows that you shouldn't only learn bash. For a while, bash was the only programming language I knew, So I made a connection monitor where you could like stalk people's connections and like kill them and like read their SSH output. And it was really bad. So here's what bash should look like if you've gone too far. So don't do that. So side note, the red team wants your scripts. If you hardcode passwords, they're gonna see exactly what you're doing. So some quick tips to hide them: put them in like a weird folder. They never check lib. Who checks the lib? What even is in there? And then when you make changes, you can touch D to set the timestamp, so it looks like it wasn't updated recently. Another tip is don't sit inside the directory, because if they check the current working directories of all the bash processes, they'll see like, why are you in libso dbus1 scripts? And disown it if it's running forever, because that's another very common thing to see in PS. You'll see like bash running the script and you're like, huh. But if dbus.sh is running disowned, I'm more likely to think that it's like something about the actual process. And if they're checking your command line history, that's bad. So you either put a space in front of it or just delete your history. So those are all the tips. So yeah. Thing would be like, okay, well that shell needs to die. If I do like, hello, my password is password one bang, and you see I put a space in front of this, then when I type history, it's not going to show it. But if I type it with no space in front of it, it's going to show it. Cool beans. I think that's the entire presentation. Oh, call to action. Learn bash if you want to do Linux stuff. Yay! And that's it. Questions, concerns? Thanks.
Don't kill yourself.
You can't stop me. No questions, no concerns. All right, thank you for coming. We hope you learned stuff.
Woo.